Hi, welcome back to statistics class. Our topic is about the analysis for two groups, specifically the Mann-whitney U test. To guide you with our lesson, our focus topic is our outline. We will discuss the background of the Mann-whitney U test and then discuss about the assumptions and discuss the formula. And for you to understand better, we will have an example, problem, and calculations following the hypothesis testing steps. Okay, so Wilcoxon-Mann-Whitney U test. So this test is used to compare whether there is a difference in the dependent variables for two independent groups. So in other words, if we want to compare the two groups, so it compares whether the distribution of the dependent variable is the same for the two groups and therefore from the same population. And so this Wilcoxon-Mann-Whitney U test is the counterpart to the parametric independent samples t-test for evaluating whether two samples were drawn from the two different populations with equal means. So this Wilcoxon Mann-Whitney U test can also be called in some references as Wilcoxon rank sum test, the Mann-Whitney U test, the Mann-Whitney test, or simply U test. And this Wilcoxon or Mann-Whitney U test is very useful for small data sets, let's say less than 20 values. And then the Mann-Whitney test is especially useful for small data sets. And there's a reminder that variables should be measured on at least an ordinal scale. So we have the four levels of measurement. We have the nominal, ordinal, ratio, and interval. So this Mann-Whitney U test, its requirement, the data must be at least on an ordinal scale. So variables should be measured on at least an ordinal scale. So the requirement of interval data is not necessary. However, the test will accommodate interval data, continuous scores, and data measured on an arbitrary scale. So what are the assumptions for this test? So assumptions of independence of observations and random sample selection should be met to assure a non-biased sample. So for example, test scores are usually measured on continuous scales, and variables such as beauty, pride, and loyalty are measured on arbitrary scales. So if the variables are on a continuous scale, the Mann-Whitney procedure ranks the observation automatically when the computer software is used. And then other assumptions of parametric tests such as normality and equal variances do not need to be met for this test, for the U test. So, however, the assumptions of independence of observations and random sample selection should be met to assure a non-biased sample. So the one assumption for this test is only the independence of observations, and the rest can be is not necessary. Or if it is equal normal or have an equal variance, that's okay. But for the assumptions for this test, it must be at least independent. And then here's our formula. For Formula 1, UI, it can only be U1 or U2, is equal to Wilcoxon value, it could be 1 or 2, minus the NI, it says the sample size for the group 1, or the group 2, and then sample size for the group 1 or group 2 plus 1 over 2. So how can we compute the W1 or Wilcoxon value? That is W1 plus W2 is equal to N1. This is the sample size for group 1 plus sample size of group 2 multiplied to sample size of group 1 plus the sample size of group 2 plus 1 divided by 2. So when we compute, W1 is equal to the summation of ranks in first variable, let's say x. And then for the Wilcoxon value, 2 is equal to the N1 or the sample size for group 1 plus the sample size for group 2 multiplied to the sample size of group 1 plus sample size of group 2 plus 1 divided by 2 minus W1. So we have taken it already as the summation of ranks in the first variable. Let's say X. So the Mann-Whitney test examines the median of the distribution for two samples to determine whether the median of one sample is larger or smaller than the median of the other sample. And then scores from both groups are combined and ranked in order of increasing size. So the smallest score rank 1, and then the second smallest score is rank 2, and then 3, so on and so forth. Take note that the algebraic sign associated with the score, say positive or negative, is considered in the ranking so that negative scores are given lower ranks than positive scores. So here's the procedure. Step 1, rank all the data values, meaning if it is group X or group Y, you have to combine all the data, then rank all the data values combined. And then step 2, sum the ranks of group X and note as Wilcoxon value or WX. And then sum the ranks of group Y and note as Wilcoxon value or denoted as WY. So the ranks in one group, say group X, are summed and noted as the Wilcoxon value. As I've said, WX. And then the next, for group Y, do the same rank and then sum all the ranks. So these ranks may be WY. So it is very important that as the scores are ranked, they retain their original group membership. The sum of ranks for the two groups should be the same as the sum of the ranks for the combined groups. And then compute for the following for step 3. So W1, Wilcoxon value for the is the summation of ranks in the first variable, or say X. And then W2 is equal to N1 plus N2 multiplied to N1 plus N2 plus 1 divided by 2. Take note that this N1 and N2 is the sample size or number of observations in group 1 or in group 2. So minus W1. So this is the rank for the first variable. And then the U1 is equal to W1 minus N1, the sample size for group 1, multiplied to the sample size of group 1 plus 1 divided by 2. And then U2 is equal to W2 or Wilcoxon value for the group 2 minus the sample size for group 2 times sample size for group 2 plus 1 divided by 2. So you have to compute for this 4. W1, W2, then substitute this value to get U1 and then U2. So step 4, denote the lower value. So it can be U1 or U2 as U to be used for hypothesis testing. So later, you'll better understand it given an example. So we'll have this hypothesis testing and example problem, and it is found in our textbook in page 103. So this is the table 4.4. It is the rank data for two combined sample X and Y. So these values, so these groupings, they are just combined for ranking. So the lowest value is 56, so rank 1, 62 as rank 2. But take note of their groupings. So here's the group X, and then here's the group 4. So they maintain their groupings, but but they have a different rankings. So in other words, the rankings is combined for all data values. Since the lowest value is 56, so it is ranked as 1. And then for 62 is rank 2, 70 is rank 3, and then rank 4 is from the group Y. So here in group Y for the ranks for Y we have here the rank 4. So after that, arranging them, we have to sum all these rankings in each group. So 56 is now rank 1, 62 is now rank 2, so I have to sum up like 1 plus 2 plus 3 plus 7 plus 10 plus 12 plus 14 is equals to 49. So this will be our Wilcoxon value for the X variable or for the group 1. Wilcoxon value 1. So this is the ranks for group X. And then ranks for Y, 4 plus 5 plus 6 plus 8 plus 9 plus 11 plus 13 plus 15 is equal to 71. So we will compute now for W1 and for W2. So we already have summed up the rank for the first variable in group X. Our W1 in our previous slide is 49. And then for W2, this is N1. Actually, this ranks in first variable, this is the lowest rank. Our lowest Wilcoxon value, this is 49. And then W2, N1 plus N2 multiplied to N1 plus N2 plus 1 divided by 2 minus W1. So this W1, we've taken it as the lower, so the Wilcoxon value among the two groups with the lowest value. So now substitute this one, 7. So because in group X, we have 7 observations, 7 plus 8 multiplied to 7 plus 8 plus 1 divided by 2 minus 49. So this is the W1. Okay, and then W2 is equal to 15 since 7 plus 8 is equals to 15 and 7 plus 8 plus 1 equals 16. So multiply that equals 240 divided by 2 minus 49. So our W2 is equal to 71. Just a algebraic operation. You can take this, you can arrive in this number. W2 is equal to 71. And then solve for U2 or U1. U1 is equals to W1 minus N1. This is the sample size for group 1. Then sample size for group 1 plus 1 divided by 2. So our U1 is equal to 49. Substitute the value for W1 that we have got in the previous slide, the previous calculations. 49 minus 7 times 7 plus 1 divided by 2 with a algebraic operation. We will arrive to this number, 49 minus 28 is equal to 21. So this is now our U1. And then for U2 is equal to W2 minus N2. This is the sample size for group 2. Let's say the group Y times the sample size for group Y or the group 2 plus 1 divided by 2. So 71 or W2 is equal to 71 minus 8 times 9 divided by 2. So our W2, our U2 is equal to 35. Again, our U2 is equal to 35. So let's have a steps to hypothesis testing. So step 1, we will state the null and alternative hypothesis. So in our statistical presentation, you have to present it this way. Our null hypothesis rather, HO is mu1 is equal to mu2. And then in a statement form, there is no statistical difference between the average ranks for the two groups, group X and group Y, in terms of, you can state your dependent variable here. And then our alternative hypothesis presentation is mu1 is not equal to mu2, or there is statistical difference between the average ranks for the two groups, group X and group Y. And then step 2, we have to state the level of significance. So we have here our alpha, 0.05. So you can state also if it is two-tailed or one-tailed. And then our test statistics. We have already computed this value, the U1 and the U2 in our previous presentation. So to summarize, W1 minus N1 times N1 plus 2 divided 2. So our U1 is equal to 21. So if you want to recalculate it, just go back in our previous slides. And then U1 is equal to W2 minus N2 times N2 plus 1 divided by 2. So our computation is U2 is equal to 35. So our computed U value is 21. So we have here the U1 and then the U2. So what is the lowest value or the lower value? 21. So we will use 21 for our critical region or for our hypothesis testing. So here is now stating our critical region in step 4. So this is fixed, okay? Reject HO if U, this is our computed value, is less than or equal to the U, this is our tabulated value in alpha, N1, and then N2. So remember that this is default, meaning it is fixed. This is our decision rule. Reject HO if U computed is less than U tabulated or U alpha, N1, N2. So where U, this is our computed value based on our data, it is equal 21. And U hints out because our level of significance is 0.05, so we will state it this way. 0.05 divide 2 because it is two-tailed. And then the number of observations in group 1 is the group X, it is 7. So there are 7 values. And then for N2, in group Y, there are 8. So equals to 10. So we will take this number the table, from the table for Mann-Whitney U test. So now, since this is our decision rule, so since 21, because U computed is 21, is greater than 10. So hence, fail to reject HO because it is greater. If it is less than, then reject HO. However, our data shows that U computed is greater than U tabulated. Hence, fail to reject HO. So where did we get the value for 10 in our critical region? U 0.05 divided by 2 because it is two-tailed. And then the N1, for group X, there are 7. And then for the group Y, there are 8. So we can take it here from the table. N1 here, we can see it here. N1, so this is 7. And then N2, this is 8. So and then the intersecting number, so since it is two-tailed, take note of this, two-tailed testing. And then 0.05, so our value is 10. So this is our critical value. Hence, reject HO if U computed is less than U tabulated, where U is equal to 21 and U tab is equal to 10. Since 21 is greater than 10, hence fail to reject HO. This is our critical region. So our decision, it is to fail to reject HO. So in other words, there is no significant difference on group X and Y. And the results of the analysis revealed no statistically significant difference between the medians of the group X. So if you have your independent variables or grouping, say female, and the group Y, say male, and then you have to support it with your literature study. So this supports the study of who that male and female can perform similar. It depends on your subject. It depends on your dependent variable you are measuring in your study. And so students, here's our remarks. Recall, so if you want to check your answer, recall that the sum of the ranks will always be equal n times n plus 1 divided by 2. And then the U1 plus U2 is equal to the sample size for group 1 multiplied to sample size for group 2. So you try it based on our example. And then when N1 and N2 increase in size, the sampling distribution of U1 or U2 approaches the normal distribution with mean computed as this. U1 is equal to N multiplied to N2 divided by 2. And the variance of in this formula. So consequently, when N2 is greater than 12 and N1 is at least 10, one could use the statistics like z-test. Z is equals to U1 minus U mu, this is mu U1 divided by the standard deviation for U1. So for our test, with the critical region falling in either or both tails of the standard normal distribution, depending on the form of each one. And then another one, our fourth remarks, the use of Wilcoxon rank sum test is not restricted to non-normal populations. So it doesn't mean that if it is non-parametric, we will only use it for non-normal populations. No, it is not restricted to non-normal populations. And it can be used in place of the two sample t-tests when the populations are normal, although the probability of committing a type 2 error will be larger. And the Wilcoxon rank sum test is always superior to the t-test for decidedly non-normal populations. So you know the assumptions for parametric test. Normality, equal variances, and independence of errors. So you have to know that non-parametric test or parametric test follows the certain assumptions. But for this, here's only the things you need to consider. So before we end, we'll read this letter. Writings from Ellen White. We must help the needy and the oppressed, lest Satan take them out of our hands, out of our ranks, and place them while under temptation in his own rank. Someday we will be placed in an eternal group. It can be group one or group two for heaven or for hell. I hope that we will help each other be in that heavenly group and be ranked as one of the heir of the kingdom of God. So thank you so much and see you on our next class.